Advanced Math, strategy number 3 for solving algebraic equations today. This is sort of the mathiest official strategy that you'll see, that you'll probably use the most often, middle and high school. It is called the inverse operation strategy. I'll remind you how it worked last time we did it, and then we'll do it for some more advanced problems now. So go ahead and make this the title of your next free page in your math notebook. Find yesterday's example. I think the we do. No, it's going to be a new we do. Never mind. So yeah, once you've got your title written down, unpause and follow along with me. All right, back in the day, back in 6th grade, we actually used this inverse operation strategy for much simpler algebraic equations than we're going to use them for today. So we learned how to solve equations like this with that strategy. Now, obviously, I think both of these you can solve with common sense. You can look at this one and say, well, I know that 5 times 6 is 30, so I know r is 6. And you know that r plus, 3 plus 17 is 20. So r equals 3. I know you don't need the inverse operation strategy to solve either of these, but I want to remind you how it works. What we said to do, we're trying to finish up with an answer that looks like this, with r equals something. So what we wanted to do was have r have its own side of the equal sign to itself. Instead of r plus 17 here, it would be nice if r was all by itself, and on the other side was an answer all by itself, and we knew what r was. So the way we got to that end was we said, all right, well, I'm going to look what's happening to r in the problem. So in this problem, 17 is being added to r. So I'm going to do the inverse operation of that on both sides of the equation. Since r has 17 being added to it, I'm going to subtract 17 from this side of the equation. And if I do that to keep everything even, I'm going to subtract 17 on this side of the equation. If I do that, this side of the equation has r plus 17 minus 17, which is r plus 0, which is just r. So that does that. So now I've gone from r plus 17 minus 17 to just r plus 0, which is just r. And over here, I did the minus 17 on both sides to be to keep everything balanced out. And 20 minus 17 is 3. And I get that obvious answer that I knew before. So since r had 17 being added to it, the inverse operation was to subtract 17 from that side of the equation and this side of the equation. Over here, say, well, what's happening to r on this side? Well, it's being multiplied by 5. So what I'm going to do is the inverse operation of multiply by 5, which is divide by 5 on both sides. 5r divided by 5 is just 1r, or just r. And 30 divided by 5 is 6, and I got r equals 6, which is the same thing we knew it was going to be from the get-go. So that's what we did back in the 6th grade part of the year for solving equations. So now we're going to apply that same logic to some problems we have done before. So yesterday we did this problem with the drawing strategy. I also want to bring that to your attention. So we did 331 students went on a field trip, 6 buses were filled, 7 students traveled in cars. How many were in each bus? So the first thing we did is write an equation. We figured out that the same number of people on the trip was equal to the people who traveled there. So we said 331 people were on the trip, and we dealt with this to make our equation. Said 6 buses were filled, but we don't know how many people were on each bus. So it was 6 times however many people were on the bus, and then another 7 who traveled there. And we solved this with the drawing strategy yesterday. Kind of said I have 331 on this side, and I have 6 of the B blocks over here. Each of these is a B. Sometimes I just draw the letter. Remember, I don't draw the blocks, so either one. And then I had 7 people. And what I did is I said, well, I know that if I know that if 331 people were there and it was all this, the number of the people just on the buses was 7 less than this. Because if I kind of say, all right, I'm just going to look at the bus people, if I ignore the 7, I can change this to 7 less, which was 324, and then I'm only figuring out the buses. If this plus 7 was 331, just the buses was 7 less people. So 324 people rode the bus plus these 7, and then I use my calculator to say, well, then I have to divide this 324 people onto the 6 buses, and I'll know my answer. So if I had 324 people and there were 6 buses, then 54 were on each bus. So when I do the inverse operation strategy today, it's actually, you're going to see me do the 2 things I already did. I subtracted 7 and I divided by 6, and you're going to see me do that with the inverse operation strategy. So here's how it works. I'm going to leave that over there so you can see the parallels. So when we do order of operations problems, we do them in this order. You know, if I'm gonna if I knew my answer here, if I was trying to calculate 6 times 54 plus 7 equals how many people, I would do the multiplication first and the addition second. So when I'm going backwards and trying to figure out a number in the problem, instead of just doing the order of operations, I do the operations in the other order. So when I have my equation here, if I knew B, I would do the multiplication first and the addition second. To figure out B, I do the order of operations in reverse. So now I'm going to add and subtract before I multiply and divide. So now I have 2 things happening to B. It's being multiplied by 6, and 7 is being added to it. So I'm going to have to do the inverse operation of both of those. But since I'm solving for the variable, I'm going to do them in the opposite order. You ready? So first thing I'm going to do is say, well, it has 7 being added. So I'm going to subtract 7 from both sides, which, by the way, look back, that's what I did yesterday. I subtracted 7 from both sides first to find just the bus people. So all I'm doing is the math equivalent of what you saw me do first over here. So since 7 is being added to B, I'm going to subtract 7 from both sides. This makes 0. So now I've got 324 on this side, and I've got 6B on this side. So now I've done one of my inverse operations, and I have to do my other. So now B is being multiplied by 6. So I'm going to divide by 6 on both sides. And if I do, then B equals, same as over here. That's what I did here, right? I took 324 and I divided it onto 6 buses. I divided it by 6. That's exactly what I'm doing here. And I'm going to get the same answer of 54. So this is what I did with my drawings. I just only did the math. You can see me subtract 7 back in the drawing, and you can see me divide by 6 in the drawing. All the same thing, I just used the inverse operation strategy. Let me do one more before we go to the we do. So here's the other problem we did yesterday. The sum of 3 consecutive numbers is 72. What's the smallest number? So this one was a little tricky just to set up. So the way we wrote our equation was we said, okay, I don't want to have A plus B plus C because it's going to be too hard to solve 3 variables. So we turned it into an equation with 1. Like A was the smallest number. The next number was 1 more. And the next number was 2 more. So that way I only had 1 variable. So I had A plus 1 plus A plus 2. Today, before I try to solve this, equals 72, I'm going to combine my like terms first. I see that I have 1, 2, 3A, so I'm going to rewrite my equation as 3A, and I'm also going to combine my numbers. So I'm going to rewrite this as 3A plus 3 equals 72, which you can easily see that it was here too. 3a plus 3 equals 72. So we already drew it that way before. I already combined my like terms. I just never wrote the equation that way yesterday. All right, so when I look at this, A has two operations happening to it. I've got to go in reverse order because I'm not evaluating, I'm solving for a number in the equation. So right now A has multiply by 3 happening to it and add 3 happening to it, and I'm going to do them in reverse gems order. So I'm going to add and subtract first. So the first thing I'm going to do is subtract 3 from both sides to get rid of the plus 3. You saw me do that here. Look, here's subtract 3, here's subtract 3. I did that yesterday. Again, it's just like the drawing strategy. I'm just doing the math version instead of the drawing version. So then I'll be left with 3a over here and 69 over here, which I was yesterday. 3a equals 69. And then all I had to do was divide my 69 into my 3a's, and I had my answer. So the 69 has a third there, a third there, and a third there. So now, since I'm multiplying by 3, I divide by 3, just like I did over there. Divide by 3, divide by 3, and I get that a equals 23, which I believe is what we got yesterday too. 3 times 23 is 69, plus 3 is 72. So that's my answer. All right, let's do one together. Open your notebook, and let's do this problem together. Nick opens a savings account with $50. Each week after he deposits $15. In how many weeks will he have saved $500? So I know Nick saves $500 altogether. He does that by putting $50 in the account and then saving $15 a week for don't know how many weeks. That's the question. $15 a week for some amount of weeks that is unknown. Weeks. All right, and so now I'm going to do my inverse operation strategy. So when I look at W, W has two operations happening to it. Plus 50 and times 15. So when I do these in order, since I'm now solving for a variable and not just doing 50 plus 15 times something, I'm going to go in reverse gems order with these two things. So I'm going to start with plus 50. The inverse operation of plus 50 is minus 50. So I'm going to subtract 50 on this side, subtract 50 on this side. When I do that, I'll be left with 450 on this side. This makes 0. So now I've got 450 equals 15 times W. And so now the opposite of times 15 is divide by 15. That's my second one because I'm doing multiplication and division second in reverse gems order. And so now I've got to divide by 15, divide by 15, and 450 divided by 15 is 30. So 30 is my number of weeks. So it takes him 30 weeks to do that. All right. Don't know if you felt that was pretty tough or pretty easy. This is the kind of sophisticated middle school, high school strategy that people usually use to solve for variables. So I definitely want to make sure you totally, fully understand it. We're going to use this strategy again the next 2 days, doing harder and harder situations. So please, please make sure you really get this first. If you want to even show this one with the drawing strategy so you can see me in the drawing, you'll see yourself subtract 50 and you'll see yourself divide by 15. You can do that. But please make sure you go back and I do's and we do's until you really get this so you come to class ready to roll tomorrow, because we are going to advance this strategy farther the next 2 days. All right. Once you're a master of this, I appreciate your